L has to be strictly greater than H of the absolute value of N minus 1. And that's actually, then this is, so now basically our result will be this, the class of quasi-orderings defined by the structure, and these restrictions are the only ones that satisfy what we think is what we have as a set of axioms that are quite mostly familiar from the literature, with a little twist, because what we do is different from what has been done in the past. Well, actually, I should say it's a generalization of what has been done. So the way we characterize this class of quasi-orderings is we basically use 4 properties, and 2 of them are just blatantly, shamelessly lifted from earlier work that Jacques David and I did. They are not all that important because all they do is they guarantee that the same number comparisons are made according to utilitarianism. One way of doing that is using what we call minimal increasingness. And that's just a very weak version of a dominance property that says if everyone's the same, for a fixed population size, if everyone's better off in one situation than the other, then the former should be declared better than the other. So if you take any population size n, and any 2 utility values are, if A is greater than A in R, if A is greater than B, then if you have a distribution where you have n times A, that should be better than a distribution where you have n copies of. That's, again, that's weaker than Parade or anything else you might want to impose. The second one is what we call incremental equity. And again, you will see this is what drives utilitarianism. He said if you have a given distribution of a fixed population size and you have some extra to distribute, it doesn't matter who you give it to. And it's clear that this will give you utilitarian. So if you take any population size n, take any given utility distribution u, utility value d, then if you start with u and you give d to someone, let's say you multiply d by the ith unit vector, then you get something that's as good as the distribution that you get if you, instead of I, you give this extra, this utility j. So that's all I and j.
This is anonymity kind of.
It implies anonymity. It's very strong. It implies anonymity, and it implies essentially that you're utilitarian. It also, interestingly, implies completeness if you restrict yourself to the same number comparisons. That's why we don't have to impose it. So that's a nice little wrinkle. We hadn't been aware of that earlier. And by the way, P is the asymmetric part of R, and I is the asymmetric part. And I'll use N, capital N, for non-comparability. Okay, these are the first 2. Then we have 2 axioms or properties that explicitly deal with variable population considerations. And we use what we call critical sets. Take any population size difference, positive population size difference k. The critical set for this difference k is a set of real numbers, that is utility values, such that if you add k copies of C to U, you're in a situation of non-comparability to the original U. So that's a way of introducing non-comparability. And and you define such a set, and you do this for all u.